Hello guys, good afternoon and welcome to our channel Software Concepts. Today I'm gonna tell you something about a software called FireElite, which is primarily used for the hydraulic calculations of sprinkler systems, fire drains and fire mains. So to start before, I would like to tell you that this system is not particularly to be used as per an FBA. Think is that this software can be used for any kind of system design as long as we meet the we follow some rules and guidelines. So in my later videos, I will tell you that how to design a sprinkler system. But just for the moment, and for this particular video, I will tell you about the interface of this Elliot software. And I have an experience of using this software since 5-6 years now. And first of all, this is the main window of the software. Uh, because yes, you will start the system from the start. So you will open new project. You can open by clicking on this tab, or you can go to file and open new. Both are the same. So once you open in project data, you can fill out the information as you want. Then the client data is all the information for your client, and then comes the company data. Yes. Okay. Is the details about you, the company you represent, and if you are a consultant running your own firm, you can fill out information as you like. And this is the building data about the building you're going to design, and here comes the system data. So this is the main window we will focus on in this video. So we will go in step by step. So on the top left corner, number one is indirect sprinkler allowance in GPM. Before I explain you further, there is an option here where you can change the units. So let's suppose we used SI units, then you can see that all these units are changed. And because we are based in Australia, so these are the system international units being used in Australia. And if you're designing system, especially with respect to NFPA 13 or 14, so I would prefer you to use the units which are the US imperial units. So this is the first thing, which we call indirect sprinkler allowance. This input is only required when you are designing a system where indirect sprinklers are. So in my later videos, I will explain that how to design a sprinkler system for rack. Racks are usually storage arrangements for stacking the goods and materials. So the second thing is called inside hosting allowance in GPM. You can put the information as required for your system as per NFPA, which would be 100 GPM or 50 GPM, or depends on what kind of hazard is. And then the outside host name allowance. And with respect to these two host name allowances, I would like to say that you can put in information, but none of this information is going to be shown on the reports. The next step is default materials. If you click on here, sorry, well, it's still okay. So if you click on here, you can see that this is the reference term and this is the material. And the number 4 is the material, which is a schedule 40 wet seal pipe, which I would recommend you to use as a default material, because steel pipe is the main infrastructure layout piping for sprinkler hardy system. And if you are designing a system for underground fire mains, then you can go and choose number 7, which is PVC class 200. If you call it on, you would have CPVC. Yes, these are different kinds of steel materials which we can use. PEX pipe is the material which is being used in Australia as well. So the thing is, all these different kind of materials have different friction coefficient. So yes, as a default, you can say number 4, but for the underground, yes, you can use PVC class 200. So 4 is the one which is recommended. Now comes to the default K factor. What's my default K factor? If you put the value of 5.6 as default K factor, it means that when you will put the nodes information here, this is another window which we will work on it later. So yes, default K factor is 5.9. So you just have to put D, so this value will pop up, and this window will be populated. And so you can, it's up to you. Sometimes there are special sprinklers, especially residential sprinklers or sidewall sprinklers, which have a different K factor. So it's up to you. So then again, this value does not have impact in the hydraulic calculations. You can mention here, or you can leave it blank. Sprinkler model is up to you. none has been defined. Sorry for that. And instead, now. Okay, so here it comes. Sprinkler model ABC, sprinkler make by Vikings. Then the temperature rating of the sprinklers is on 130, but if you put 160, again for a high sprinkler size, which usually normally comes in 1.5, liberty it does not need to fill in. So authentic records is not useful. Here is the most important item to be filled in. So primary tower discharge, here are two different options. One is hose and one is sprinkler. So if you have a hose, so then the default K factor will change, and if you select here as a sprinkler, so yes, K factor would be more or less about 5.6. But if it is a hose and you are designing a system as per NFPA 14, then default K factor would most probably 25. And just for information, just leave it a hose. These are the commands. Like if you put any commands, these commands will show up in your report. I would recommend you put no commands here, and even if you put the commands, unless you don't click on the include these commands in the report, it will not pop up. And this slide window is fairly important. So hazard identification here, hazards has been identified as per NFPA 13, and if you close the lights, hazard identity, and then the minimum desired density comes in. So obviously, if you select the hazard description is light, obviously you will choose the first one, which is density of 0.5 GPM per square feet. And sorry, we have to change here hose sprinkler, and sprinkler system type is wet, obviously, and type of sprinkler operation. So area of sprinkler operations in square foot as per NFPA for light hazard occurrences is 1,500 square feet, and maximum area of sprinkler per sprinkler is 256. So maximum area of sprinkler operations, maximum area of per sprinklers we have defined. And then we goes to hard test data. Hard test data is this is information which is being provided by the client in your building. Let's suppose client says that the closest hardness for the building is A71, which is source of information is owner. Hardened ID is A71. Sorry about hardened test date. Owner is saying that the hardware was tested 1st of October 2024. And hardened elevation said that is 3. So all this information shall be shown in your report, and definitely the reviewer will. Sorry to say that he's asking me to save the project. I will save the desktop. For example, so here we are, and hardened elevation is 3 foot, and I was saying that all this information will show up in your report, and all this information will provide some sort of insight to the reviewer, and reviewer will see all this information in your report. And here comes the exterior hose allowance. As long as you did not click this allowance, your system will not consider the demand in your final calculations. Just for example, you design a system and the software says that your system needs 150 GPM at a reservoir pressure of 75. And if you uncheck this thing, and even if you have mentioned here 100 and 100 GPM here, still system would not say that the demand is 100 GPM, 150 GPM plus 200 GPM for the hose. No, but if you click here and whatever your hose launch here you mention here, then your system will say that the demand at the riser of the system will be 100 PS, 150 GPM for the sprinklers, and 100 GPM for added particular test pressure. So again, this is static test pressure in PSI and reservoir test pressure in PSI. If you fill out this information and you're gonna run your calculations on a supply mode, so this information is important. And if you're gonna run your system for a demand mode, but because owner has provided you all this information, so you can fill out this information like test static pressure as to the hardened is 100 psi, and test reservoir pressure is, let's suppose, 70 psi, and test flow rate during the test hardened was able to provide a flow of 1000 GPM, just for an example. So then your system will run the calculations based on input. So this was the main window which you have to populate before you go to the next window, which we called enter bar data. And on this window, you have to just give the nodes number from 1 to 1000. You can give any nodes numbers you like, but in the next examples I will tell you that how you're gonna populate these. But just for as a brief, I'm just telling you that where information you have to put. So this is the node, this is the material. You just have to specify the material and loss in PSI. Software will calculate by itself. And because in default we have said that default pipe material is class 4, so that's why its default middle pipe is 4. Dia, if you say that this is 4-inch pipe, length is, let's suppose, 10 feet from node 1 to 2, K factor, if, because definitely this could not be a sprinkler, so we're just going to leave it blank for the moment. Sprinkler elevation, it says sprinkler elevation, but this is about the elevation of the floor. And if this is your beginning node at the alarm check wall, I suppose, or the hydrant which is feeding your system, and the elevation is 3 foot. Just put a 3 foot. And estimated pressure loss, you don't need to populate these 2 tabs. And area, sprinkler area square foot, you don't need to actually, not even need a group. And non-sprinkler flow, no need. What is saying this will be used as a fix on it of stream right now. Yeah, so because index sprinkler allowance is 0, so yeah, this information, it would be 0. And here comes the standard feeding, I suppose. And if from point 1, node 1 to node 2, if it's 1 gate wall, you just say 1 gate wall. And if you have 2 gate wall, I suppose 2 gate wall and 3 elbows. So this is the way you specify the standard feedings from point 1 to 2. And so yes, that's it. Once you fill up all the information, you just have to click this button, which is called calculation. When you go to calculations, it's saying this would be this is very important, mark inflow node. And yes, when you at the end of your system calculations, when you go here, when you press this tab with the computer icon of calculations, there are 2 different modes of calculation. One is called demand and one is supply. So demand is most commonly used, where you have to define the minimum reservoir pressure at the hydraulic most disadvantaged sprinkler node. As by an FBA, it is the 7 psi is the minimum pressure required, and minimum discharge density. This density comes in from the information provided here, and this density is fixed for your hazard description, and that's it. And then these 2 things which you have to put some information. Especially this value comes from 0 to 4. So, in my case, I just put 2 here, and that's it. And when you press security, he's saying you should specify the maximum node pressure imbalance for the calculations. Okay, and let's suppose if we say 0.05, and if I say calculate now, it's not calculating because it is too much information missing on this window. So in our next videos, I will tell you that how to populate this window with a real-time example. And this video was just only about to tell you that how you fill up the first window, and these are the main 4 tabs which are being used at the moment. This next tab is for the report. Once your calculations are run and system calculations are run and system, it will give you that particular demand, flow, and pressure. That click on this window and you can print here. And this is what the save icon. Everybody is familiar with this. This is a closed icon. These 2, 3, and 4 icons are the same. If you have to add the pipes, which comes on a latest data in the pump database as well, and these are options. These are the units which I have told you before. And this is about sprinkler K factor calculators, which I'm going to tell you later on. But just for an example, that just as I told you, if you click here and if you change your primary tower discharge from sprinkler to hose, then you need to specify the K factor. And what would be the K factor if you need a hydrant to flow at 100 psi and 100 psi and flow rate of 250 GPM as per NFP24, so K factor would be 25. So in that case, so this is these icons will help you to calculate the K factors of sprinklers and branch lines. For branch lines, we don't need it. So yeah, this is for this video, and please don't forget to like and subscribe. And in our later videos, I will tell you how to design a sprinkler system. And here we go. Thank you.